This video will discuss ionic bonding that involves polyatomic ions and transition metals. So we learned the crisscross method in our previous lesson on how to write simple ionic formulas and how to name them. We are going to kind of layer in now, talk a little bit more about those transition metals, and we'll also talk about those polyatomic ions because they have charges and will participate with ions of opposite charge in ionic bonding. So the rules that we need to remember for that is that if a polyatomic ion needs a subscript, you must use parentheses. And I just want to remind you of rule number 7. If a final answer has subscripts that can be reduced, so the subscripts for every element in there can be all divided by the same number, they must be reduced because we need to be true to that formula unit, which is the lowest whole number ratio of those atoms. Again, this is for ionic compounds only, and that's all we're dealing with here today in this video. Okay, so those transition metals, we use the Roman numerals to indicate the charge of the metal atom. Metals are always positive. They're always going to lose those electrons. So whatever the Roman numeral is tells you what number goes with the positive charge. So copper 1 is 1 positive, but copper 2 is 2 positive. Iron 2 is Fe2 positive, and iron 3 is Fe3 positive. Here are your Roman numerals in case you have forgotten what those symbols mean, or at least as far as we will be using them here in this class. Okay, so these were the ones we practiced with yesterday, and we did some pretty simple crisscrossing with those atoms that tell us the metal atoms are going to indicate with the Roman numerals what their charge is going to be. And then when we were naming them, we could simply uncrisscross in order to get the charge of the metal atom. Like for this one, here, we know that this is going to be iron and chlor, and then we add IDE to the end. But iron is one of those metals where we have to indicate the charge, not the subscript, the charge. So where did this 3 come from? Well, bloop, 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 bloop. It came from up here, and it was iron's charge. So this is iron 3 chloride. All right. So I have a couple of more to practice with. And this first one here is lead for an oxygen. So that means I've got lead, and the 4 means that it's 4 positive. And then oxygens in group 16, it likes to be at 2 negative. The sum of these charges is not 0, so I need to crisscross. So that means that 4 is going down here, and this 2 is going down here. So when I crisscross, I get Pb2O4. Well, in this situation, I have a substance where both elements have a subscript that is divisible by 2. So this doesn't adequately represent the formula unit for lead 4 oxide. So we have to reduce this, and we're just going to divide those subscripts by 2. So it'd be PbO2. This one is the lowest whole number ratio of those atoms. So if you don't run into this very often, but when you do, make sure that you do reduce those down. Again, it's only for ionic compounds. Okay, the next one that I have is tin, 2, and sulfur. So 10 is Sn, and its charge is 2 positive because the Roman numeral here tells me that it's 10-2. Then I have sulfur, and sulfur's in group 16, so it likes to be at 2 negative. Here, I don't have to crisscross because it's an even exchange of electrons. 10 wants to give up 2, and sulfur wants to gain 2. So I'm just going to rewrite the atoms without their charges, because I don't have to get anyone else involved. And so the formula would just be this. Now, if we didn't know that it was 10-2, and we're only given this, how could we figure out the name of this particular substance? Well, I know that Sn is 10, and then S is sulf, and it's an element, so it ends in IDE. So 10 sulfide, but we need to indicate which 10 it is. Is it 10-2 or is it 10-4? Well, I can't uncrisscross anything because I don't have any subscripts here. So what we're going to have to do is we're going to have to actually figure out what the charge of 10 is. And we're going to do that with our knowledge of formula writing. We know that the sum of the charges has to equal 0, has to. And we know that sulfur likes to have a 2 negative charge because we can look that up on the periodic table. It's in group 16. That's what elements in group 16 do. So we didn't crisscross because I don't see a 2 over here. So that means it must have canceled out. And for it to cancel out, this would have to have the exact same charge, or 10 would have to have the exact same charge but opposite sign as sulfur. So for them to add up to equal 0. So that lets me know that 10 has a charge of 2 positive. So it is 10-2 sulfide. So sometimes you can uncrisscross. Other times you have to deduce by using your knowledge of formula writing what the charge is so you can put the correct Roman numeral in there. All right, now let's talk about ionic compounds and with polyatomic ions. So you're going to treat a polyatomic ion as one thing. And it will behave, and then formula writing is just as simple as it was with those simple ionic compounds. So let's say for a nitrate, when we bond something with a nitrate and write the formula, I should be able to look at the formula and see, oh, it's a nitrate. And part of what makes a nitrate, and all the polyatomic ions what they are, is their existing subscripts. So existing subscripts must stay with the polyatomic ion. They are part of its identity. We're only going to be crisscrossing the charges. So remember, if a polyatomic ion needs a subscript, use parentheses. So let's say I have calcium, and it's going to bond with nitrate. Nitrate has this existing 3 subscript. That should always stay intact. So I should always see an NO3 in our final formulas. You're never going to bust up a polyatomic ion, ever. All we're going to do is we are going to crisscross the charges. So here, the charges do not add up to equal 0, so I know I have to crisscross. And the only thing that's going to move there is that 2, and it's going to go to the bottom of the other ion, so in this case, nitrate. Now, I'm going to talk about this rule right here, that if a polyatomic ion needs a subscript, you need to use parentheses. Because if you don't, and it should look funny at this point, it's saying something that you don't really mean. This is saying we've got calcium bonded to a nitrogen and 32 oxygens. And that's completely impossible. What we meant to say is that we've got calcium bonded to 2 nitrates, and adding the parentheses does that. So when you have to add an extra subscript to a polyatomic ion, you put the polyatomic ion in parentheses and the subscript you're adding outside of the parentheses. So a couple of others, be careful with hydroxide. Don't let hydroxide get you. So calcium likes to have a 2 positive charge because it's in group 2. And if it's going to bond to hydroxide, hydroxide is OH negative. Now, the reason why hydroxide gets students is because it doesn't already have an existing subscript. So often students forget those parentheses. So we're going to crisscross. The only thing that's going to move is this 2, and it's going to go to the bottom of hydroxide. And this is not the correct answer, because this says we've got calcium bonded to an oxygen, which is bonded to 2 hydrogens. And what we meant to say was that calcium is bonded to 2 hydroxides. So watch out for hydroxide there. Remember, we also have positive ions. Those are our polyatomic ions, which are our ohms. So like this is ammonium. So ammonium can bond to another polyatomic ion that has an opposite charge. So let's say it bonds to carbonate. Again, we're only going to be crisscrossing the charges here. The existing subscripts must stay. So here, the charges don't add up to equal 0, so I'm going to have to crisscross. The only thing that's going to move is that 2, and so I've got NH4, but I'm going to need 2 of them, and that's where that 2 came from, and then carbonate. And that's ammonium carbonate there. So I have some for you to practice, and here they are. You can pause this video and then I'll go over the answers. Okay, so the answers to these practice problems are as follows. Check your work, see how you did. Here, watch out for hydroxide. Make sure you have hydroxide in parentheses there because we did have to add a subscript. Here, this was an even exchange of electrons. Sodium wants to give up 1, nitrate wants to gain 1. Here, the only thing that's going to move is that 3. I don't have to use parentheses because I'm not adding a subscript to a polyatomic ion. I just added a subscript to lithium. And then ammonium hydroxide, we compare their charges, positive and negative. It's an even exchange of electrons, and so this is the correct answer here. Now, naming ionic compounds that involve the polyatomic ions is actually easier than naming them with ending in an element. So with an element, what we had to do is you write the name of the first element, then you write the root of the second element, and then you add IDE at the end. Well, the same thing's going to apply to things with polyatomic ion, or at least the first step. You write the name of the second element, and then you are going to, if it ends in a polyatomic ion, you don't change the ending. You basically just name the polyatomic ion. So this would be magnesium hydroxide. This would be sodium nitrate. This would be lithium phosphate. Again, no changing of the ending whatsoever. You're just naming the two pieces. Ammonium hydroxide.